Boy Chase doing some randomness with some science experiments for a school project. So, let's get it started. First experiment off with the typical baking soda and vinegar. So let me get that set up real quick. I almost forgot to mention, when you do these experiments, make sure you have protective gear like gloves and goggles. So yeah, so we're gonna go with the vinegar and the baking soda. My cat would get out of the way so we don't get soaked with it. Here we go. And as you can see, it's fizzing all over the ground, And make sure you're not wearing your good shoes, so you don't mess up your shoes. Make sure you're not doing this inside, because you don't want to mess up your inside. So I'm wearing boots. So if I mess up my shoes, I'm stepping all in, all the vinegar. So if you mess them up, it doesn't matter. All it is, play shoes, but it doesn't matter. But oh well. So that's my first experiment. So let's get to the drawing board and so you know why this happened, why this chemical reaction occurred. Drawing board, and it simply started like this. You got your bowl, and the green represents the baking soda. I made a key. Anyways, the red is the bowl, the green is the baking soda, and this is the vinegar. And that's how it started. But then simply, when you come over here, when you mix the vinegar right here, mix the vinegar with the baking soda, it causes a chemical reaction, causing it to foam up and over the bowl. And that's why that chemical reaction occurred, as you just seen. But yeah, let's do another experiment. Alright, so now on to this experiment. This is the Alka-Seltzer and the water experiment. I'm not sure how this one works, but here we go, test one. Begins to fizz, bubble. Well, it didn't do what I expected. I expected like over fizz like the vinegar and the baking soda. I still got some, this from the baking soda, it's not snow. Still from the baking soda and the vinegar. Anyways, yeah, this is what this doing. I expect to do more, but make sure you always, have your protective gear. But I thought it would do more. But all it is dissolving, Thought it was gonna do more, but it didn't. And I don't know if this can harm me, that's why I'm wearing protective gloves. But if you're doing this and not wearing gloves, don't pick them up like I am. Like I said, never ever forget that you need protective gear when you're doing a home experiment. Always have your goggles and your gloves. But yeah, that's all this is doing. This is foaming up. I can steer it around. Although the water's awfully cold. But yeah, I'm steering it around. The fizz is still there, the bubbles. And it's foaming up, Yep, seeing this experiment. So let's go back to the drawing board. It's just like the last experiment with the baking soda and the vinegar. You got your bowl, your water, and your Alka-Seltzers. If you didn't hear what I just said, here's the key: bowl, red, purple, water, orange, Alka-Seltzer. So it's just your water and your Alka-Seltzer. That's the beginning. Then over here is there's 3 Alka-Seltzers in the water. There's water, and I messed up on the bowl, but the pink represents a chemical reaction, and when I put the Alka-Seltzers in, it started to fizz. It did not run over like the vinegar and the baking soda, but it just began to fizz all around in the water until the Alka-Seltzers were dissolved. And here's the key: bowl, water, Alka-Seltzer, chemical reaction. On to our next experiment. Just a pencil, right? You can snap it right in half. Once this pencil is snapped right in half, it is a physical reaction, because all I did was break it right down the middle. Now I can put this back together somehow. Wait, hold on, I'm almost there, and I messed it up. Alright, simply messed it up. Let's try one more pencil. My last pencil, so break right down the middle. Now, if it didn't mess up so bad, you can tape this right back together and there it goes. Tape this thing right back together, right there, and be a usable pencil. But, eventually, somebody's gonna come by and, hey, look at your pencil, bam, or bam, and then it falls right off. Yeah, that's gonna happen. but it's still a physical reaction because you put it back together. It's just a break. It's something you can easily fix. It's a change in shape. It's still a pencil. It just broke in half. All it is a change in shape, but you still have both halves, so it's a physical change. Now, if you was to burn this half, it's a chemical change, but you still have this half, so it's a physical change. Back to the drawing board. Experiment started like this. So here's the key: eraser, pink, orange pencil, graphite, black. And you start off with a simple pencil. Then when you got to do the experiment, you still have your eraser, your pencil, and the graphite, and then your physical reaction. Here's the pencil, and then there's where I broke it. So it's no longer one pencil, it's two pencils. All you have to do is just sharpen this half. On to our next experiment. Now this experiment that we're on now is a more cautious experiment. So you want to do this experiment with your parents, because it involves fire. And if your parents trust you with matches or fire, make sure you're doing it outside so you don't burn down your house. I'm outside of my house, but make sure you don't burn down your house. And simply, what you want to do, just have an ordinary pencil or something like a paper plate or a napkin. But for me, I'm using a pencil. Then you simply want to light it, because pencils are flammable. They're made of wood. See if I can get this going. And you can see it's burning the paint right off and real quick. Well, I expected to burn a lot more, but it's burning the paint off, and because the flame is hot and the paint that it's made with is flammable, and it's going out. Hold on, how about that? So I can get it going again. Maybe not. There it goes. Alright. Now that it's actually the wood. The wood is flammable because it's made from trees, and trees are flammable. The wood is actually on fire because it's flammable. Now I'm holding it up, which is a big mistake because the flame will rise faster if I'm holding it up, which I'm holding up and I can feel the heat. But it's also rising fast because the paint's flammable and the wood's flammable. But simply, if you're doing this experiment, you definitely want to try it with an adult and not to get burned. Like I said, if you're doing that with your parents, you definitely want to try that with the parent. I mean, not encourage you to try it with the parent. But if you do that experiment, you want to have your parent around, or if they trust you matches and you're outside and nothing big can catch fire. I'm gonna do one more experiment just because I have a cardboard box next to me. Maybe I don't. Alright, a newspaper. A newspaper. Not a newspaper. A piece of paper. Alright, so you can see, oh shoot. Alright. Well, you can see this piece of paper's on fire. It's because it's flammable, and there goes that piece of paper. Let me stomp it out real quick. And it's flammable because it's paper. And same thing with the pencil. They're both made from trees, and they're both flammable. So, if you do that, make sure your parents there, and you can't burn anything that much. And if you do leave it burning, if you light it and drop it like I just did, make sure you put it out onto the drawing board. Just like the last experiment. I have my eraser, my pencil, my graphite. Then down here you have an ordinary pencil. Then you go over here, still have the eraser, the pencil, the graphite, and the chemical reaction, also known as fire. Down here it was a normal pencil until I lit the fire with the lighter. And then it began to burn up the paint, which I did not draw. It began to burn up the paint and burn up the pencil. And it's a chemical reaction because you cannot put it back together or reuse it. Once it's burned, it's burned. You can't reuse it again. So that's why it makes a chemical reaction. On to our next experiment. For this experiment, I have a simple cake. And what makes this chemical reaction is, for example, well, there's two chemical reactions were happening right now. Well, not right now. One chemical reaction was, it took raw eggs, some other stuff, some icing, some chocolate on top to make this cake. The second thing that makes this chemical reaction, oh my god, this cake is so good. The second thing that makes this cake a chemical reaction is when it hits when it's somewhere in your stomach. I think it's the lower, no. I don't know what part of the stomach it is. But when it sits in your stomach for, I don't know, a day or two. Maybe, no, not that long. Maybe like a few hours. It begins to digest in your stomach. I think it's 4 hours exactly. No. I'm just taking a wild guess here. But when you eat the cake, in about 4 hours, it should be digested into your stomach until it just... Well, we all know what happens next after digest in your stomach. But, back to the drawing board. In that experiment, you have your bowl, your cake mix, and your eggs, and your oven. Here's your eggs, here's the cake mix, the orange, and your red's the bowl, and here's your oven. Well, so after all these combine into one substance, as known as uncooked cake, once it is bowl, cake, frosting. Once it's baked in the oven, it comes out to be bowl, the cake. Well, it's still in the bowl and it has a cake now. And then once you cool it down, you frost it, and now you get yourself simply a cake to eat and share with friends. On to our next experiment. If you do this experiment, you want to make sure it's okay with your. Actually, you want to buy a spare bowl, that your parents have never seen. But I do not recommend doing this because you could get hurt and you could get in trouble by your parents. But if you have a bowl, a spare bowl, basically, this is a physical reaction, yeah. Basically, somehow that did not break. Okay, let's back up and try that again. Okay, well, oh my gosh. That was a bowl, and I did not expect that to happen. Good thing I did not get hit with it. So that's what I'm saying, guys. It exploded right there in like a million pieces. That's what I'm saying. That was very dangerous. I could have just took my eye out, and oh gosh, I could have took my eye out with that one. So that is a very dangerous experiment. I recommend not doing that. As you're seeing, it just like it literally exploded in front of my eyes and yours. So I recommend not doing that one. Board. Experiment, you have your bowl and a rock. Here's your rock, here's your bowl. So you already know what's gonna happen, and you just saw the video. So on this side, after you throw the bowl at the rock, on this side you have shattered bowl and a rock. You still have the rock. The rock won't ever change, but you still have your rock, and there's the shattered piece of the bowl. Now this is a physical change, because if you took the rest of your life, you could put that bowl back together. That is a promise. You could put that bowl back together. It would take the rest of your life, but you could put that bowl back together. On to our next experiment. Now this experiment is very dangerous because it requires an open flame and alcohol. So I do not recommend you doing this. If you want to see how this actually works, ask your parents to do it for you. Simply, I'm going to take some rubbing alcohol and dye it somewhere. And then basically, without blowing my hand off, I recommend you not doing this because it's very, very, very flammable. It's almost like gasoline, but not gasoline. So I recommend you not to do this. Let your parent do it if you want to see it. And I'm showing you this. Yeah. Alright, never mind. I joked myself. I said it was very flammable. I thought it was. Maybe I'm getting it confused with gas. And with this experiment, it's chemical because, it's chemical because it's burning the cardboard, and you can't get the cardboard back once it's burned. And this is chemical too, because it's baby powder, and it's flammable too. Now you just learned something new. You learn something new every day. Now you know that baby powder is flammable, so do not try this in your house, because it's very flammable. Not very, but flammable. But, what? Alright, maybe not. Maybe it's a certain baby powder. Wait. Usually says on here, hold on. What the heck? Wait. Alright, well, one time me and my brother were using baby powder, and it actually was emitting fire when you done that. But now that it doesn't, so never mind. It totally messed up. But it still has some alcohol, so let's see if I can fix this. Very dangerous, don't attempt. As you just seen, I dumped a liquid chemical onto an open flame and it causes more flame. Well, it causes more fire, so I recommend you not to do this. Let your parent do it if you want to see it. But yeah, each time I add alcohol, it causes more fire, so do not do this. That's simply that. And I totally messed up because I'm not wearing safety pin. I just got alcohol on my fingers, so do not attempt this. And putting that rubbing alcohol in there is a chemical change because once it melts, it's gone. You can't get it back. Pretty much already said this, and it just bursted if you just heard it. But yes, after that happened.